Hello, and today's purpose of the day is I can use sine, cosine, and tangent to find side lengths. Please take a moment to read page 649, the Y section on trig ratios, and answer the following questions. For the warm-up, determine if the triangles are similar. If so, write a similarity statement. Do you think the triangles are similar? Well, let's take a look here at triangle PQR and STU. These lines right here, by angle P and angle Q, represent that those are equal. Here on S and U, with the two lines through the angle, that means angle S and angle U are similar, and angle P and angle R are similar. So if we're looking at all the angles, we know that angle Q and angle T are both 55 degrees. So if these two other angles, P and R, are going to be the same or congruent, we need to figure out what those will be. Well, there's 180 degrees in a triangle. And if these two angles, P and R, are the same, then 180 minus 55 is 125, and divide that by 2 because angle P and angle R are the same, we would get 62.5 degrees for both angles P and R. The same thing would apply then to the next triangle, STU. 180 minus 55 would be 125, divided by 2 would be 62.5 degrees. 62.5 degrees. So these two triangles would be similar because their angle measures are congruent. Then, to write our similarity statement, we would say triangle QPR, so we'd line up the angles, QPR is similar to triangle. Now we have to line up these angles with the current triangle. So Q measures up with angle T, because they're both 55 degrees, so triangle TSU. I could also say on the reverse, triangle QRP is similar to triangle TUS, so I just have to make sure that I line up the angles with the corresponding triangles. All right, the second example here, triangle ABC and DEF, let's see if those are similar. Well, 180 minus 84 minus 59, this would be 37 degrees here, but 180 minus 39 minus 59 is 82. So all of these angles do not match, so these triangles are not similar. So we would just say not similar. We could say even further because angles are not congruent. All right, so we are beginning trigonometry, which is the branch of mathematics devoted to solving triangles. Three main trig ratios are sine of angle A, cosine of angle A, and tangent of angle A. So those are some symbols to represent angle. And we have a triangle over at the right, and I will describe more about those letters and what they mean. But sine of angle A is equal to opposite over hypotenuse. So what that looks like here is, here's angle A. Angle A matches up with little side A. So I could draw an arrow, and directly across from it is little a. So that's side A. It's always directly opposite of the angle which matches with that letter. So here, angle A matches up with side A. So the sine of angle A represents opposite, so this would be the side opposite of angle A. So it would be A over, and then what's the hypotenuse here? Well, the diagonal, which would be this side right here, so it would be C. So the sine of angle A is opposite, which would be side A, over hypotenuse, which would be C. Cosine of angle A is equal to adjacent over hypotenuse. So here, if we look at angle A, cosine is adjacent. Adjacent is a key word for right next to. So the side right next to angle A would be this side because it's directly in line touching angle A. So that would be B over, now the hypotenuse we know still is C, so B over C. So the adjacent side could not be C because C is already the hypotenuse. So cosine of angle A would be side B over C. Tangent of angle A, tangent is opposite over adjacent. So the tangent of angle A here would be opposite, which would be the side opposite, which would be little a, over adjacent, which would be, again, the side that's directly touching angle A, which would be B. So you can see we have a different variation of all the letters, A, C, and B, and those will change here to turn into numbers here where we'll figure out missing measures. So again, just to recap, adjacent means the side across from the angle measure. Adjacent means side directly next to an angle. And hypotenuse means longest side or the side across from the 90-degree angle. Again, those were just a recap of what the words opposite, adjacent, and hypotenuse mean. So to recap one more time, sine is equal to opposite over hypotenuse. If we wanted to turn that into a mnemonic device, we could say so, because sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. So again, for a mnemonic device called ca, cosine, adjacent, hypotenuse. And tangent, again, is equal to opposite over adjacent. So toa, tangent, opposite, adjacent. So what you could say to help remember, that's a common math term in trigonometry, is so, ka, toa. So, ka, toa. For sine, cosine, and tangent. So let's take a look at an example here. So sine of angle A. So here is angle A. So let's look at this with numbers. And this is the 90-degree angle right there. So let's see here. Sine is opposite over hypotenuse. So the side that's opposite of angle A here would be 5 over hypotenuse. Here would be 13. So 5 over 13. And again, that would be opposite over hypotenuse. So right now we're just figuring out different, what matches up with each trig function. Cosine here it would be, so angle A is adjacent, so side that's directly touching, that's not the hypotenuse. So adjacent would be 12 over the hypotenuse, which is 13. Tangent, again, is opposite over adjacent, so tangent of angle A would be opposite, which would be 5 over adjacent, which is 12. So just some practice, again, on matching up side lengths with their correct trig function. Now, before we get into solving for missing side length here, we want to look at using our calculator properly with using these trig functions. So please locate on your calculator right now, and you will need to make sure you know how to do this, sine, cosine, and tangent. They're about in the middle of your calculator. Sine is right next to the pi button, and then cosine is next to sine, and tangent is right next to the division button. So using your calculator, round to 4 decimal places. Let's type in number 1. So please type in sine of 31 degrees. And so when you click sine, you'll see sine with a parenthesis come up, and then you'll type in 31 and then close parenthesis, and rounding to 4 decimal places, you should get 0.5150. Now let's try cosine of 31 degrees. So you're going to type in cos, and then it'll show a parenthesis. You'll type in 31, and you'll close the parenthesis. Rounded to 4 decimal places should give you 0.8572. And then rounded to, we already rounded to 4 decimal places. Now tangent, so you'll type in tan, and you'll see a parenthesis. 31, you'll close the parenthesis, click enter. Rounded to 4 decimal places is 0.6009. So again, just testing out to make sure your calculator is in the right mode. If it's not, I can help you with that when I see you to fix that. It should be in the degree mode. And then just making sure that you know where to locate the buttons on your calculator. So now we're going to see how this actually applies to find a missing side length. So we're going to look at a couple examples. And when we solve for a missing side length, we're going to round to the nearest tenth. So I put a little reminder right there. So round to the nearest tenth. So let's look at this first one, triangle FED. So we know 40 degrees, and we know 2 sides. We have one that's 15, and then we have one that's just x. So we know 2 out of the 3 sides. That's all you need to know in one angle to find all the other missing pieces of the triangle. So today we're going to look at solving for a different side. So we want to solve for side x here. So if I'm given 40 degrees, so this is angle D, 40 degrees, I know the opposite side, or that's what I want to figure out. And then this long side, this diagonal, is the hypotenuse. So we have to think about what goes with opposite and hypotenuse. Sine, you got it. So I will say here, sine of the angle, which is 40 degrees here, sine of angle 40, is equal to opposite, which is x, over hypotenuse, which is 15. So sine of 40 is equal to opposite over hypotenuse, which again is x over 15. So now we need to solve for x. This is just a one-step equation. So I would multiply to get rid of 15 in the denominator. So if I multiply by 15, I have to do that to both sides. So then in my calculator, I will type in 15, the sign button, 40, and hit equals, and you should get, rounded to the nearest tenth, x equals 9.6. All right, let's try another example. Here we know, again, angle 40. We know this side and this side. So I know, and I'll change some colors here. So I know the adjacent side, and I know the hypotenuse. So what goes with adjacent and hypotenuse? You got it, cosine. So I'll say cosine of 40 degrees is equal to adjacent over hypotenuse. So now to solve here for x, I'm going to multiply by 20. So I'll get 20 cos 40 equals x. Rounded to the nearest tenth, what do you get? Great job. X equals 15.3. All right, let's take a look at this last one here. So I'm given 40 degrees here, I'm given the opposite side and adjacent. So what goes with opposite and adjacent? Tangent, you got it. So tangent of 40 is equal to opposite over adjacent. And then to solve for x here, I would multiply by 18. So 18 tan 40 equals x. Rounded to the nearest tenth after I've typed that in my calculator, I get x equals 15.1. So now we're going to look at 3 different examples, which is a slightly different setup, but we're still going to solve for a missing side length. So let's look at the first example. I'm given an angle, and I know the opposite side and hypotenuse. So this goes with, opposite and hypotenuse goes with sine. So I will say sine of 32 equals opposite over hypotenuse. So this is just a slightly different setup than the other 3 examples we went through. Before, we had x in the numerator, now we have x in the denominator. So if we want to solve this equation, what we could do here is we could try to get x out of the denominator and multiply by x, so they cancel out on the right-hand side, and I get x sine of 32 equals 15. Divide by sine 32 to get x by itself. And so I would get x equals 15 over sine of 32. Now all of that work, and really, what did I just do? Well, I just basically just flip-flopped where x and sine of 32 were in my original equation. So we can keep that as a shortcut as we go to some other problems, and I'll show you again what that looks like. So now in my calculator, I would type in 15 divided by sine of 32. And what I get for an answer, rounded to the nearest tenth, is x equals 28.3. All right, let's look at another example. Let's go to the right here. So I'm given this angle, and I know the adjacent side and the hypotenuse side. So adjacent and hypotenuse goes with cosine of 32 is equal to adjacent over hypotenuse. So again, when you have x in the denominator, the little trick was to flip our trig function in x, because we know that's what we'll get to eventually. So if I flip those right now, I'm going to get x equals 17 divided by my trig function of cos 32. If I type that into my calculator, what do you get rounded to the nearest tenth? You got it. X equals just 20. All right, let's look at our last example here. So I know this angle, and I know the opposite and adjacent. So it's going to go with tangent of 32 equals opposite over adjacent. Again, this different setup with x in the denominator. Flip our trig function in x for a little shortcut and get x equals 10 divided by tan 32. Type that into my calculator, rounded to the nearest tenth, and I just get 16. So this was one other way of setting up a trig function, our trig ratio, to solve for a missing side. Thanks for listening. Please see Schoology for more information. Have a great day. Bye-bye.